So hello guys, welcome back to my channel. Hope you're doing extremely well. So it's a day 24 of solving the POTDs provided by the Geeks for Geeks. Okay, so what does today's problem say? Today's problem says that we have to merge two sorted linked lists in reverse order. Let us look at the problem. Yeah, as it is pretty evident by the name itself, we have been given two lists which are sorted. Alright. As you can see in the examples, 5, 10, 15, 40. It is a sorted linked list. And the another linked list is 2, 3, 20. That is also sorted. So we have been provided with two sorted linked lists, and we have to provide a merge solution in reverse order. That means if I merge them in a sorted order, what would be the merging? It would be 2 will come first. Okay. After that 5 will come. Okay. After that 3 will come. Yeah. 2, then 3, then 5. 5. After that 20, 10. After that 15. After that 20, and after that 40. This will be by my merge list of the list 1 and list 2, the sorted merge list. I just have to reverse it. That is, it will become 40, 20, 15, 10, 5, 3, 2. And I have to give this node as my answer. This is my linked list, and I will have to provide this as my head of the linked list. Alright. So how will we approach the problem? Pretty simple actually. This is a basic linked list question. Actually, this is a mixture of two questions. That is, merge two sorted linked list and reverse a linked list. Okay. So it would be similar if I had made two videos of reverse order and merge two sorted linked list. This is just a mixture of both of them. Okay. So what is the brute force approach? Brute force approach says store all the numbers of both the linked list in a common vector, correct? And after that, sort that vector. Okay, and then third point is create a new linked list from that vector. So what did we do? We for the given example, we made a vector which contains 5, 10, 15, 40, then 2, 3, 20. We sorted it, which gave us 5, 2, 3, 5, 10, 15, 20, and 40. And with the help of this vector, this sorted vector, we created a linked list that looked like this. And at last, we will reverse the linked list. And at last, reverse the linked list. Or to save this step, you could have just sorted it in the decreasing order, or sort it in decreasing order. In that case, you will just return the head. You will not have to reverse the linked list. Okay, in decreasing order. Okay, I hope the brute force approach was clear to you. Let us know in our time complexity analysis on it. So as you can see, to store all the numbers, we will require O of n time, n plus m actually. To sort them, O of n log n. Okay. To create a new linked list, again O of n. And to reverse, again O of n. Okay. What is the time complexity? O of n log n, the maximum of all these, because these all are separate. These are not nested in each other. Okay, so O of n log n is the time complexity. What is the space complexity now? Space complexity is to store all the numbers you would need a vector of size n plus m, so it would be O of n. Pretty inefficient, right? Not an efficient algorithm. What can we do? If we somehow manage to merge in O of n and reverse in O of n, we could get a pretty efficient solution. Also, the solution I'm going to tell you will use a space complexity of O of 1. That is no extra space. How can we do that? So my approach says that you have a linked list, say L1, and you have a linked list, say L2, correct? I say merge these two. How will you merge them? For merging them, we will do. Let me try write down examples again. Yeah. Now, so for merging them, what can we do? Our L2 is pointing here actually, and L1 is pointing here. Okay. We'll create a new head which will store the final linked list. L2 value is smaller than L1. So put L2 in head. Okay. 2. Move L2 forward. Okay. Now L2 is still less than L1. So it will be 3 here. Okay. Move L2 a step forward. Now L1 is smaller than L2. Put L1 here. Move L1 here. Okay. After this, 10 is still less than 20, so L1 will come here 10. L1 will move forward. Okay. 15 is still less than 20, so 15, that is L1 come here. L1 exits. It was 40. Sorry for my mistake. So L1 now L2 is less than L1, so it will be 20 here, and L2 will exit. Now when L2 exits, either L2 exits or L1 exits, put all the remaining elements of the linked list into the remaining linked list into the final answer, that is 40. Okay. So as you can see, we have got a sorted linked list. I will tell you the pseudocode how will we use the pointers to merge them. Sorted linked list, just reverse it, and we have got our answer. Okay. How can we do that? For doing that, let me write the pseudocode for you. The pseudocode says my head is initially null and my temp is equals to head. That is, it is also equals to null. All right. Now my L1 is pointing here actually. My L2 is pointing here. Okay. I will run a loop while L1 and L2. That is, both of them are not equals to null. If L1 data is smaller than L2 data, that is L1 has a node with less value, what do? We make our temp. Actually, we first check if head equals to null, assign that value to head. That is, head becomes L1. All right. If head becomes L1, automatically temp becomes L1, right? And move L1 to L1 equals to L1 equals to L1 next. All right. After that, what do we have to do? Else, if it is not head, then what are we doing? Then temps next equals to, that will be else, sorry, here else temps next equals to L1, and then L1 equals to L1's next. This is our else block. This for if L1 data is smaller. Similarly, replace L2 and L1, that is else, that is L2 is smaller. In that case, again, if head equals to null, what do you have to do? Head is equals to L2, and then L2 changes to L2's next. Okay. Else, same steps, both of them same, but just replace L2 with L1. All right. Now after the loops end, that is either L1 has become null or L2 has become null, what do we do? If these are the steps after this while loop, if L1, that is L2 has become null in this case, If L1, then temps next is L1. Okay. Else temps next is L2. Alright. I hope the pseudocode was clear to you. Okay. Now this will give us a merging in O of n actually, if you see, because we are just traversing the lists. Okay. So merging, our goal was to merge in O of n, that is achieved. Now reversing in O of n, that will be also achievable. How we are going to achieve it? So reversing a linked list is a separate problem, okay? But I'm telling you in this video only because you have to solve your POTD for today. So our new problem is reversing a linked list. Okay, how we are going to reverse it? So for reversing it, what we are going to do? Let me take an example. So for example, our linked list is first 5, then 4, then 7, then 9, and a desired linked list is 9, 7, 4, 5. Here 9 is pointing to null, and here 5 is pointing to null. Okay, what will I do? I will name my head as a temp here. Okay, my next would be temps next, and my previous would be null actually right now. Okay, now while next is existing, while next, what do we have to do? I change my temps next to pref, that is temps next is equals to pref, that is the previous element. So it will go here. Okay, after that, my pref would be changed to temp, and my temp would be changed to next. And my next will move further, that is next will be equals to next of next. Okay, this is a problem in this pseudocode, what I will show you. So if we are dry running it, so initially the temp was here, next was here, pref was here. As a first step, temps next is pref. Okay, then pref comes here, p comes here, t comes here, and n goes here. Okay, again repeating the loop. This will come here. Okay, p will come here, t will come here, n will come here. Okay, again doing that same. This becomes cut, this becomes this, and then p will come here, t will come here, n will go null. And well, if n goes null, loops break. Okay, so if you are able to observe, as soon as null next becomes null, we are not able to establish this connection to the previous element. So what do we have to do after the loop ends? We have to execute this statement again. Temps next equals to. I hope you are getting the gist. What I'm trying to tell you, that this was not implementing in this loop. This arrow was not being implemented in this loop. So for that, what did you do? We set temps next is equals to prep, and we solved our matter. Okay. I hope this is clear to you. Again, what is the time complexity? Time complexity is O of n. How we are only traversing it once time. Okay. And now space complexity, as you can see, we have not used any extra space. Okay. So what did we do as a whole in the problem? We divided the problem into two parts, which were merging linked list, and second was reversing the linked list. Time complexity for this was O of n, space complexity was O of 1. Similarly, time complexity was O of n, space complexity was O of 1. Add them up, it will still remain O of n and O of 1. So in whole, it is a better and the most optimized approach to solve this problem. I hope you are getting my point. Okay, if you have got, please hit the like button and please subscribe to my channel. Okay, it gives me a lot of motivation. So without any delays, let us code the solution, how we're going to approach it. So yeah, so my first base case is if both the values presented to me are null, that is, all there is no element, in that case return null. Why are you incrementing your work, making work more complex? If both are null, return null. Correct. Else, if this condition is not satisfied, that means three cases can occur. Either node 1 is null, or node 2 is null, or both of them are not null. So if node 1 is equals to null, what can we do? That means w- or our merge list will be node 1 plus node 2 only. That will be node 2. So just return reverse of node 2. Correct. Similarly, if node 2 is null, at that time return reverse of node 1. Correct. Okay. Now our first step was to merge the linked lists. Okay. So when node star head becomes equals to merge node 1 and node 2. Correct. And after that, what we'll do? We did reverse the linked list. Reverse the linked list. That is, so my head will become equals to reversal of the linked list associated with head, and at last return your head. Okay. Now I just have to implement the merge and the reversing. Okay. Let me implement the reversing first. That was uh, both of them are easy, but reversing is still more easier than compared to the merge. So what did I get here? Node star. Let me name it as node only. Okay. So here I did in node star temp equals to node. Okay. Node star prev equals to null. That is my previous point. And node star next equals to the existing temps next. Now while next is existing, what do we do? Temps next changes to prev, and after that prev will become temp, temp will become next, and next will become its next. And as we discussed, we have to implement temps next equals to prev one more time after the loop, that is this one. At last our answer will be stored in the temp variable, so return temp as your head now. This is our code for reverse. Now we have to just implement the code for merging, so that is node star merge. That is, here it will be node star actually. This is a typing mistake. It will be node star node 1 and node star node 2. Now our head is initially null and our temp is initially head, as we discussed. Now what did we do? Now while node 1 and node 2, if node 1's data is actually less than node 2's data, in that case what do we have to do? The condition is if head is equals to null, so assign that value to null. That is, head is equals to node 1. Node 1 will change to node 1's next. Else attempts next would be equals to node 1, and then node 1 will be equals to node 1's next. And also we have to move the temp forward for the next iteration, that is temp equals to temp next. We have to do similar things for node 2 data, that is control C control V. That's why I'm using the copy paste. Just have to replace node 2 with node 1, that is node 2 data is less than node 1 data. For that, head 2 will be equals to node 2, right? Node 2 will becomes its next pointer. It will be temps next will become temp, and this will be doing same, and this. Yeah. Now after that, if one of them ends, now if node 1 was not null, that is we have our temps next is node 1. Alright. else temp next is right. At last, return your head. Okay. So I hope we have not committed any mistake in writing our code. Let's run it down.